Okay, welcome to OpenExpo 2008 in Bern. Does anybody not understand German? Okay. One person. So let's try in English. I really would like to welcome Alan Cox here in Bern. Welcome, Alan. It's a great honor to have you here in Bern. It's the first time for you in Switzerland.
Yep.
So that's cool, and it's great to have you here. So first of all, I'm sorry to most of you to have be standing here or wait outside of the room. Maybe you're wondering why the government track has such a large, basically empty room, and here's very crowded and small. The thing is that we thought that as you are already the followers of free software and open source, you like to have it a little bit more kind of cozy and more community. And on the other hand, the big government decision makers, they need a little bit more persuasion how to use and if use open source at all, and therefore a little bit more space to think. And so, but the second point is we all record the speeches today. So if you're not here and if you can't hear this message, you can see the movie later on next week. Okay, so I'm stopped talking and would like to give you the word. Thank you very much and welcome in Switzerland.
Okay, so today's talk is supposed to be about communities, process, this kind of thing in the free software world. The obvious starting point, we talk about communities. So first thing people always ask, what is a community? What do we mean by the word community? And the most obvious thing is a set of shared purposes and values. So in other words, it's a group of people who all believe to some extent the same thing. There are various things it's not. All the people in the Linux community, or set of communities that are the Linux community, are not the same. They're not all friends. You may have noticed, for example, that there are various people who don't get on with each other. If you'd like an even better worked example, have a look at the BSD community. But we have our own collection of people too. And there are people who are seeing a way of getting something they benefit from, something that helps them out of something which helps everybody else within that community. We have a lot of very different communities as well in the Linux space. So we have people like the big businesses, the banks. They have a very different attitude to the kind of people who think, ooh, new kernel release, must try the beta. And a lot of the banks are old kernel release. Can you show me someone who has run it for 3 years reliably, and then I'll talk to you? They're very, very different sorts of people. We get people increasingly now who are technology fans. So not necessarily people who are into free software, but people who are into gadgets, into interesting pieces of software, new ways of doing things. We get free software people, what are called free software believers, people who actually think that free software is the right way of doing things, people who want to change the world for the better, people who want to demolish Microsoft, all with different motivations, but all believing in free software for various reasons. And we have embedded developers who pop up now and then and say, it's too big, make it smaller. And we see a lot of embedded systems using Linux now. And also, not just embedded devices produced by large companies. We're increasingly seeing people buying small embedded boards or embedded products, reprogramming them, making them do different things. Things like some of the wireless routers people have redesigned, and some of the games consoles now run Linux. People always ask this, especially business people. Says, I have a piece of software, how do I build a community? Is it sort of like building a wall or building a house? It's not. If you want to build a community around a piece of software, it's like building something around a restaurant. Firstly, you need good food. In this case, you need good software. You need software which does things that people actually want. You need a reputation, a good one. If people don't like the things you are doing or the people, they won't come. You need a nice atmosphere. This is something a lot of people forget. There are lots of ways of persuading people not to be part of your community. And one of them is not to treat them very well. You need to treat people who come into any community well. Make them welcome, help them, show them how they can help the community and become part of it. And you need the other customers. And these other people who are part of your restaurant or your free software project have to be people you can get on with. If the other people in your restaurant are unpleasant, then people won't come. And the same is true of free software projects. And in the business world, there is a saying that everybody is in marketing. And what people mean by that is the actions of everyone who is part of a project affect how that project is seen by everybody outside it. It's not really quite like a restaurant, because you don't go into the restaurant and say, I've had a brilliant idea, here's a new menu. And you very rarely get to turn and say, I'll be chef today. They think you're a bit odd if you try that. So it's different in the sense that one of the things everybody can do is to become part of the community. And they actually influence what is being created, how it is being created, and become part of the creation of the software itself. And that raises the question, how do you coordinate this? In a restaurant, if everybody changed the menu and walked in and said, I am chef today, the result would be chaos, bad food, soup all over the floor, whatever. And okay, nobody destroy the furniture just yet. We don't really have a formal structure in most free software communities. So nobody sits down and says, you're in charge of something, these 3 people are your junior managers, this group of people will work under you. Instead we have an ad hoc structure. So the structure just appears. And this used to be a bit of a mystery. I mean, how does a free software project end up with a core team, with key maintainers? How does somebody end up in charge of translations? How do you end up with somebody who manages the mirrors for downloads? And what we see are things called emergent control structures. And what that means is you can't split the project up and say, oh, this property comes from this person or this group of people. There are properties which appear as you put groups of people together. In the same way, if you take a bicycle apart, you get 2 wheels and a frame. None of them has the property of being the bicycle or a bicycle. A bicycle is something you create out of the bits. And the properties it has about being able to ride places are properties of the whole, not the parts. So we see a sort of order emerges from the chaos. And there's an economic incentive at work here. Because if you want to be part of a community and get the most benefit from it, you don't want to be doing all the work yourself. So even if somebody else is doing part of the work and you don't quite like the way they do it, you have 2 choices. Either you do it yourself as well, which takes a lot of time and effort, perhaps more than you have, or you accept that it is being done in a way which isn't quite how you like it, but is good enough. Any community also, as part of its coordinating, has to accept that there are many goals. Everybody in the Linux community does not have the same goal. They all want it to do different things. They want to run Linux on 8,000 processors. They want to run Linux on tiny embedded systems. They want to run reliable Linux systems in their bank. They want to compile every package from source code and optimize it for their machine. All these different groups of people. In the distribution world, you see GNOME and KDE, and you find very few distributions that only have one. Because, for example, if the Fedora project said, oh, we'll get rid of KDE, the end result shortly afterward will be 2 Fedora projects, because that would be too big a change for people to accept. So you try and build something which meets, as best possible, the needs of all the community. There are good reasons for having these structures. If anyone has tried to build their own distribution from scratch, you will have discovered it's a very hard job. So one of the reasons you get distributions is that if you've got 500 people building one package each, it's much easier than one person building 500 packages. And you get specialization. If you have a large number of people, the chances are you have somebody who knows about the compiler. You have somebody who understands Emacs Lisp. If you're really lucky, you have somebody who genuinely actually understands Perl rather than fixes Perl scripts. So you get these specialists, and that means you can do the job better. You also need a distribution network. You need mirror sites. You need to tell people about it and get people downloading and using the software. And you need to collect all the bug reports and information back and do things with it. It's very, very hard to do on your own. It can be done. Some of the very early Linux distributions, when it was a very small community, were done by one person. That has not been the case for over 10 years now, for any mainstream distribution. It's always been a large number of people. You also get what are called network effects. There are various things which mean the value of a distribution, how useful a distribution is, depends on how many people use it. Exactly the same thing happens with the telephone or the fax machine. So the first telephone in the world is completely useless. You have nobody you can talk to. The second telephone in the world makes the first telephone in the world very, very vaguely useful. By the time you've got 1,000 telephones, then 1,000,000 telephones, they become really useful. And the same thing happens with distributions. The more people you have in a distribution, the more people you have to create packages. The more packages you have, the more likely it is for anybody joining your community that the software they need is already packaged. All the things they need are already present. The more people you have, the more support you have. The more people who will look at a bug and say, oh, I know what's wrong with that. Or, yes, I also have the same wireless card as you. Here is how I set it up. And you get exposure in the media. If you look at coverage in computer magazines, particularly in the mainstream, in newspapers, in general magazines, it is only the big distributions that get coverage. So magazines and newspapers will write about things like Ubuntu. I haven't seen many newspaper articles about Gen 2 or Linux from scratch or all the smaller distributions. And that has the effect that people don't hear about them. So even if Gen 2 is your perfect distribution, the first distribution you will discover will probably be something else. What are we doing? Another thing we have to do is track bugs. In the perfect world, we don't ship any bugs. In the real world, we ship lots. So one of the processes that goes on through distributions and through things like the kernel community is to collect bugs. And the more information you collect, the more you are able to actually look at bugs and say, there is a pattern, or spot which bugs are most important, which bugs need fixing first. The bug that 200 people have filed reports of, or the bug that one person has filed. So you get all this useful information. You get it also from things like email. We now have tools like Smalt, which can collect system information, which is really useful, because you can start saying things like, does everybody with this bug have such and such piece of hardware? Which is very, very useful. We've also done that with very, very big companies, people who own tens of thousands of PCs in their corporation, where they've actually done statistical analysis and p-tests and probability tests. And actually say, statistically, we are 95% certain that the bug is connected to this piece of hardware, which can be very, very useful. Putting all this stuff in Bugzilla is one thing. You can do that all you like, or in Debian Bugs, or all these other systems. You also have to do something with the information, or people get upset. So why do I file bugs? Nobody reads them. So you need people within the community who are actually Bugzilla specialists. And they look at the people who actually spend their time looking for patterns in bugs, responding to people saying, you know, can you supply me your boot messages for this bug? Do you have this piece of hardware? Asking all the questions in advance of bugs being fixed. We're trying to improve on this. Arjan van der Ven has been working on tools which collect oops reports from kernel crashes. And not only collect them in one place, but actually match them up. So you start to, you know, lots of people see this particular kernel version, this particular crash. So we think it's important, it needs looking at. Maybe we can find the pattern. And regression tracking is something which is dealt with differently according to what you're dealing with. In the kernel community, we look at regressions, we keep an eye out, we try and fix them. If you look at how regression testing is managed in things like Red Hat Enterprise Linux or the SUSE Enterprise product, it's very tightly managed, very strict, very important that there are no regressions. Because the part of the community which they market to really cares that the software continues to work as before. On the security side, in order to share information between all these competing distributions, we have a group called VendorSec, Vendor Security. And that acts as a bridge between the distributions, so we can share security knowledge, a private place to share security reports. So if one distribution finds a serious security hole, it can talk to all of the other major distributions and say, look, we all need to fix this. We need to fix it. Agree, for example, that we will all release the fix at midday next Monday. And it provides a place as well to deal with the kind of the larger security community, the security companies, notifications from big vendors. And also it goes into the FreeBSD world, because we share a lot of software with the FreeBSD people. So therefore we share the notifications with them too and work with them. So with all this, why do we have standards? But it seems a bit strange that a very large number of people get together at random, and from this a standard appears, and even a need for a standard appears. And one of those reasons is that every Linux distribution spends all of its time saying, we're different, we're Debian, we're not the same as anybody else. We're Ubuntu, we do it differently. We're Gentoo, we compile from source, we're the only people who do this. But in actual fact, most of what matters between all these distributions, at least in terms of code, politics is a different matter. In terms of code, is the same. So one of the things we have to do, we have standards for, is to help all of the people outside the community or within the community understand what is different, what's special about a distribution, what can I program to which will work everywhere. How do I write software that just works? And so it helps us to understand what is common between the various parts of the community. It helps vendors of software, proprietary software and free software. I mean, proprietary vendors clearly want to ship binaries that run on all systems. But free software developers do prefer it if they don't keep getting bug reports saying, I can compile it on Fedora 8, it won't compile on Fedora 7, and it won't compile on Debian. They don't. This is nuisance, it wastes time. They want to put out a piece of software source code and it will compile, it works on everyone's system. It also helps some of the communities, because there are small interest groups. There are groups of people who otherwise get forgotten, where standards are really, really important, because the big community often will overlook them. A classical example of that are the disabled, because most people who write free software are not disabled. In addition, it's actually a complicated topic to understand how to write software which is accessible to disabled users. So we have standards for that. We have software which implements that in things like the GTK toolkit, in bits of KDE, so that you don't have to worry about this. And the same way, that standard allows people who write the software to use these facilities, to enable disabled users to use the software, to write the software once and have it work on all the distributions with all of the packages. One of the discussions that we had a few years ago was, do we have a stable kernel release and a development kernel release? It used to be the case that we had 2.2, which was stable, 2.3 was development software, 2.4 was stable, 2.5 development. And this caused quite a few problems, because a lot of people found they had to use the development kernel to make their hardware work, because you either had an old machine, stable kernel, or you had new machine, new hardware, didn't work with the stable kernel. In addition, it was kind of halfway. It was stable, and it was too stable for some people, not stable enough for others. So at one of the kernel summits, we decided that actually this was the wrong model. We should just have a kind of rolling, hopefully reasonably stable development model. It means that certain things, like people who want no regressions, the banks, big government systems, can't easily just take a kernel from upstream. But it's a hard problem. It's actually very, very hard to maintain a piece of software without making mistakes, without shipping a version where something that used to work stops working. So we, as a community as a whole, decided, well, there are people who are experts at this. They're some of the distribution vendors. They make all the money from doing all the hard work, so we'll let them do all the hard work. And so we simply decided, well, you want to ship a very stable kernel, this is your problem, enjoy. And one thing that has happened from this is there are actually people outside it, people in the free software community said, actually I do want a stable kernel, and there are groups of people who maintain 2.6.16 stable kernels, and there's been a process now where people are releasing point releases. So as well as 2.6.24, there's 2.6.24.1.2, which are just the small fixes, the little things that missed the release, or the things that we only learned about after we shipped it, everybody installed it, and all of the email comes in going, you've broken this. In the upstream kernel, we try and avoid regressions. We don't want to ship a product or a piece of software that you install it and your machine stops working. At the same time, if we don't make changes, we can't make progress in the forward direction. One of the things that happens every time you make an improvement is you increase the risk of breaking something else. So we have this cycle. We keep improving things. We try to make sure we don't break too many things along the way. We try and fix all the things we break. In the kernel community now, we actually have somebody tracking regressions properly in Bugzilla. This is quite new. It's an interesting experiment, and it seems to be working quite well. But unlike, for example, an enterprise product, if we have minor regressions, we don't care. It's often the case that for the general good, for the majority of people, it is better to ship a new release than wait until all of the bugs have been removed. Because we might never release anything if we did that. So we're trying to work for kind of a sort of a general good. Is it in most people's interest to ship up everything else better and small known problem? And the important thing, of course, is code improvement. So if we don't get the code better, why are we doing it? So in the kernel community, we have a contribution agreement. That's primarily there to keep the lawyers happy and to keep everybody else happy that the lawyers will stay happy and somewhere else. The code gets reviewed by a mix of people. So there are people who are particular specialists who will look at it. There are people who might randomly look at a patch because they're bored that evening. And we have we have an acknowledge and a knack process. So if you post a patch, people will look at it, They might make comments saying, maybe you should improve this, maybe that part is wrong. They may even disagree with each other reviewing the code. And some people may give it a knack. In other words, they say, yep, I'm happy that that code is ready to go in the kernel. And they may also give it a knack, which means I'm horrified. This code is just totally the wrong way to do it. Get rid of it, don't put it in the kernel. And this goes round and round until everybody's kind of happy that that piece of code is right, or they're bored arguing with it. Exactly like standards, there's a certain point where people decide that, okay, I'm not happy with this personally, but I am tired of fighting a battle about it. Clearly, lots of people really want it to happen. And it normally produces code and people who work with, not against the community. Sometimes we get problems because people, particularly large companies, have this idea that we are a large company. We do it this way. This is our company coding style. This is our company policy. And they get a little bit surprised when the kernel people go, I like that, it's nice code. Put it in the kernel style. Don't do this. This is our policy. We are the kernel. And we don't care what your corporate policy is. This is a community software. And we as the community have a set of standards. Generally speaking, the key maintainers decide the architecture. So people like Dave Miller decide how networking works. And on top of all that, Linus Torvalds occasionally makes overall decisions or says, we are going to try this particular approach. Sometimes just because if there is an argument going on, the worst answer is to keep arguing, and choosing any of the alternatives and seeing what happens is better. And these maintainers change over time. Sometimes they get overruled. The x86 maintainer was recently overruled by Linus, and on the grounds that Linus and everybody else thought differently to them. And we had a change of maintainer as a result as well. And the last thing I want to talk about on the slides is branding. Now, this is something you normally associate with companies, and you think about, what is brand, logos, all these things. But you find branding everywhere in free software. So whether it's things like a Debian swirl, or it's a Red Hat Enterprise Linux trademark with a big warning notice about how you may or may not display it, it all serves the same purpose. And there's an identity. With each distribution, you look at it, there are certain beliefs and values that go with that distribution. So you look at Fedora, and there are things, everything will be free software is a decision. You look at Gentoo, and part of their kind of brand values is everything latest, greatest, compiled myself, go faster stripes. Or you look at, for example, Red Hat Enterprise Linux, CentOS, and SUSE, and the brand values there are, our software is boring. It does exactly the same as last time you asked. Nothing has changed. We was actually a discussion a long time ago in the early days of Linux. There were some SCO people at an event. This is the old SCO. The people who actually wrote software and delivered products and things. And somebody said to the SCO guy on the stand, your system is really boring. And the marketing guy for SCO said, thank you. Because he knew it's exactly what his customers wanted to hear. This software does not do anything exciting, as it actually appeals to certain groups. So brand actually, as well as identifying saying this is our set of beliefs, it identifies who the intended users of a piece of software are. So for example, I think most people who go to the websites of various distributions will rapidly get an idea about, hey, that's what I want, that's what I'm looking for, or I'll try this one, but I don't really like the look of that one. It tells you what services are included. Particularly the enterprise products, the branding is about all of the supporting facilities, training and things. It's very important to them. And in other cases, it actually says, look, there is no service. This is the whole point. This is what we do. It tells you about quality. And quality is different things to different people. So part of the branding or distribution is telling people what to expect. Now, this is a very stable distribution. We do things in a very slow and careful way. Or, we are really exciting. Admire our flashy logo kind of approach. And so it helps set expectations. It helps people understand. what part of the community this software is aimed at, what I should expect from it. So even though people think of branding as always kind of a business and marketing thing, it's very important for the communities. It identifies the values of the community, the goals of the community, says who the community is really for. And you see very different, you only have to look at, 3 or 4 distributions there. Fedora, everything is very close to bleeding edge free software. Debian, you have the things like the stable releases, support for very large numbers of architectures, a great deal of political background. So a lot of Debian is about philosophy and ideas around that. Red Hat Enterprise Linux is designed to be enterprise, boring, same for SUSE. Gentoo is for people who are the software equivalent of taking their car apart, adding faster stripes and tuning it. And that seems to give some people a great deal of pleasure. Well, it's great. It's a fantastic way to learn how to do anything, is to take it apart, discover you don't know how to put it back together and learn how to. So this serves in a very, very important place. So, and we should be about right. Yep. So, if you're coming from sort of the outside, I think most people here already know a lot of this. If you want to understand more about how random groups of people, random groups of anything, you end up with order and patterns. Why does the internet have a structure? Why do we have a small number of dominant search engines? All of these questions. Then Lengths by Barabati is a good initial read. And if you search for the name, you'll find his website quite easily. And on that, there's a lot of much more rigorous mathematical and academic research about this area of graph theory. And I warn you, the mathematical side of it is really, really, really horrendous. So most people probably just want to read the book if they're interested. Linux Weekly News has, as well as all of the new things, has a lot of good articles on things like the kernel development process. They've done articles recently on who are the Linux contributors, which companies, which people, who actually creates all of the code, what do the patterns look like. And at a more kind of academic and research level, the European Union FLOSS project and now the FLOSS Pols project is trying to do serious social sciences research on things like on the free software community, how it works, what needs to happen to make it work better and improve the competitivity of Europe, this kind of thing. And so they've done a lot of research which tells us things like something like 3/4 of kernel contributors have at least a first degree. And they can tell you what percentage of kernel developers have a PhD, which is surprisingly high. And so there is a lot more to look around if you want to understand more about what the community is, how it looks, how it really works. And usefully, these are people coming from the outside applying fairly rigorous methods to it, which means the answers they get don't always agree with the community's view of itself, which is sometimes very slanted. And that's the end of the slides, so I don't know how we are for time. Okay.
So thanks a lot for this first part. I think now we have time for questions. And I'll give the mic to, well, I'd like to give it to each and all of you, but who goes first? Okay, nobody goes first. So I do have a question, of course. You know, I'm always interested a bit in the personal side of things, behind the people that get in the positions as yours. So, can you tell us a few words how you got into all this?
Me, by accident. It's a very, very serious answer. I was working on a multiplayer adventure game, which had been my previous interest, and I'd been involved in the games industry doing similar things. And I needed something to run it on, because it was getting a bit creaky on an Amiga. And PCs came with this funny Windows thing that was no use at all. I'd looked at Minix, it was kind of interesting, but didn't really do the job. So I downloaded Linux to see if I could get my software to run on it, and started up fixing bits of the very early Linux to make it work. And somewhere along the way, I stopped working on the game and started working on Linux. And at some point after that, I ended up with Linux being involved in my job, and then I ended up working for a Linux company. But it was not planned. I didn't get up one morning and think, I will become a free software developer. There was no grand plan. I just sort of fell into it. And I think that's true of a lot of people.
Yeah, sure. Well, when talking about history, we could as well talk a bit about the future. Just some words, I guess, what you expect in the following months, years, and decades for the kernel.
That's always hard. Following months, hopefully getting things like real-time Linux properly merged. So you'll be able to do reasonably good real-time with a standard PC, standard Linux kernel. There are various things going on around power management, which are getting better and better. A lot of that is application code. The big area of work, and one which is very short of developers, if you're interested in that, is probably the X server at the moment, getting all the graphical support, 3D support for all of the new graphics cards. And that's something where, unfortunately, everybody thinks of the kernel. Kernel is cool, kernel is wonderful. I want to be a kernel developer. And one problem we have is very few people get up in the morning and think, I want to write C library code, or I want to work on the X server. And it's really unfortunate because the X server is a fantastically complicated piece of software, and you get to play with really cool hardware in really interesting ways. But there are very few people working on that, and that is actually slowing the whole thing down, because there are not enough people to get all these new features in, to get all the really cool things happening. So that's an area, I think, going forward a year or two, that has to be improved upon and fixed, so we actually get the benefit of all the 3D graphics. And beyond that, a lot of it is going to depend on what the hardware vendors create. I mean, will we still have hard disks in 5 or 10 years' time? If we do have hard disks, how do I check a 10 terabyte hard disk? How do I make a backup of a 10 terabyte hard disk? So all of these kind of questions need answers. And there is research type work going on into file systems where people are trying to find the right answer. Even to questions like, how do I check a file system which has a damn it bad block? I can't check the whole file system on a disk, on a really large disk. It takes too long. Can we build systems where you check part of the disk? Can we build systems which are self-healing, so the disk sorts itself out automatically over time? And that's a very, very big area of research, I think. The other trend, which is hard to predict, is small devices. We see a lot of Linux embedded. We're starting to see Linux in phones. So the question there becomes, how much of the kind of home appliances, how much of the tech toys you buy in the shops become Linux-based? And what impact does that have on Linux? Do we need smaller Linux? Do we need yet better power management? Do we need more hardware support? And it's very, very hard to predict these kind of things. So...
Yeah, I see. Okay, now definitely I think you have a little time to think about your questions, because this is the opportunity, you know. So please take it.
No. Oh, over there.
Could you tell us what you think about the project of the Free Software Foundation of a microkernel?
The GNU, the Herd microkernel project. Yes? The GNU, the Herd project. A long time ago, the Free Software Foundation had a choice between building a system based on the Mach microkernel, which was Herd, or taking something like Uzi, which is a very early free Unix system. Linux and BSD are not the first free Unixes. There have been 2 or 3 previous ones that died over time. There were good reasons the Free Software Foundation selected Mach, because they were anticipating a world where you were still big computers with lots of users. And so Herd was partly designed to allow large numbers of users to do their own thing. So you can have your own file system design, but at the same time share the machine with other users. Now the PC changed all that. We now have more computers than users. And everybody has about 10 computers hiding in their pocket, on their desktop, in their backpack. And so the Free Software Foundation made a wrong choice. Not something you can kind of criticize people for, but something just because the information available at the time they made the right decision, in the long term was wrong. Had they picked Uzi or one of the other very early Unix kernels, probably Linux would never have happened, because by the time Linux started to happen, there would already have been a good working Free Software Foundation kernel. But that's history. Do I think it has any future? I don't think so. Not really.
Anybody?
So I guess earlier you wrote, you had time to write code. Do you still have time to write yourself things, or do you just get to look at code from others and to decide and discuss with people?
There were times in the past when I spent all of my time working on other people's code, merging it and reviewing it. At the moment, I am not actually maintaining any specific chunk of the kernel, so I'm actually working on writing driver code, redoing all the locking in the serial layer. So I'm actually writing code these days again, which is nice.
So you like it better to write code than to decide on code, or?
Code is easier to debug than people. Should we put it that way?
Hello. Actually, how often do you meet personally with Linus and the maintainers?
Probably once, twice a year. If
Only.
And some of them we sort of know each other a bit. I mean, some of us, it's not necessarily all friends either. I mean, Linus and me, this are very, very different people, so we're not really friends. We just work together. You know, it's very much a business relationship. I'm kind of loud and stuff, and Linus is very Finnish, so we don't go together. But we meet each other occasionally. I mean, some people obviously live close together and meet each other a lot. But it's usually enough. I mean, just meeting occasionally in person means you understand people better when they're online. You have a better idea what they're trying to mean when they say something, which is useful.
Okay. Well, thank you. It comes a time which the core is OOP, also object-oriented programming in the future.
Most of the kernel is object-oriented.
Yeah.
It's written in C. If you look at the kernel, you will see a lot of things like the struct inode, struct file, and the device structures. They all have attached structures which have a list of methods in them. So we're using C and function pointers to implement classes, and that gives us control. In C, you understand in C exactly what is happening. If you use C++, it does lots of things you don't expect at random. And it's very hard to write a kernel that way. So we don't use C because it's the best language. We use C because it's the best. We don't use C because it's the right language for the job. We use it because it's the best language for the job at the moment. Some point in the future, somebody might write a sequel to C which is not C++, and which gets object orientation right, and we may look at that. But for now, we're programming in C but object oriented. Okay? No, go.
The discussion about GPL3. What do you think about, will kernel 1 change to this license, or will it remain on GPL2?
The kernel will remain on GPL2, at least for the foreseeable future. The big reason for that is that Linus in particular feels that a lot of people contributed code to the kernel. So even if it was legally possible for him to say, oh, we will be GPL3, it would not be morally right, because he would actually be saying, thank you for your contributions, and particularly to some of these companies, thank you for your contributions, you may no longer use our software. And that's not a fair and honest thing as he sees it. So the kernel will be staying GPL2. A lot of other software seems to be switching, but it doesn't cause a problem having a GPL3 libraries and applications on GPL2 kernels. So it should not be a problem.
Thank you.
I would love if Linux as a distribution really is on not 10, 20, 30% of the desktops and laptops and really overrule other operating systems. So we try from we try in some parts of the industry, in public organizations to do so. So from your perspective, what can be the main drivers to make that happen in the next 5 years, independent from public organization or industry or from the community?
I can't speak for Switzerland. I mean, most of my involvement in this is in the United Kingdom. And the biggest problems we see in the United Kingdom are about people, not really about software. Our public organizations are very conservative. They always want another public organization to have made the change before they do. And that in turn makes it hard to do things. The second issue is around software. So we've seen big companies use Linux on the desktop. And one reason is that they say, oh, we have 300 people there in production who need Office software. They only use Office software, we will save a lot of money, we will give them Linux. But in smaller companies, it doesn't work like that. So they look at it, they go, oh, Linux, oh, this is really neat. OpenOffice, yes. Accounting software. Our accounting software that understands the British tax system is only available on Windows. We won't use Linux. And so there is this problem of getting all the software you need available in order that people can start using it. The positive side, though, is that you get network effects. So every time you add a user to Linux, another Linux user, another Linux adopter, that adopter is more valuable than most of the previous adopters because you've made the community bigger. You've now made the network bigger. You've made the things available bigger. And so as you get more and more people using something, it actually becomes easier to get more and more people using it again. So you get a sort of snowball effect. As we go down the mountain, we get bigger and bigger. And hopefully at the bottom, we end up with world domination and 90% market share. At which point, we have to remember not to become evil. That is, I think, a real serious danger. If Linux replaces Microsoft, the community will be in a position of tremendous power. And there will be the same things, there will be the same temptations, the same risks that have led Microsoft to do things that a lot of us don't like, will be there for the free software people. And we would be very, very careful about that if we ever succeed.
What do you think? Andrew Morton said once that 85% of today's kernel development is done in employed work. What do you say? How many percent is done by volunteers today?
From the Floss Polls research data, Andrew's numbers are about right. About 85% of people working on Linux are paid to work on Linux. And that's obviously very useful. But there are a lot of people working on Linux. So there is a very big volunteer community. And it's not a case of, oh, they all work for somebody. There are quite a few people who do it as a hobby. And one of the reasons I think we end up with this 85% as well is that the distributions keep hiring all the people who do it as a hobby. So they keep sucking people in. Also, the 85% figure includes people who are paid to work on Linux, not because they work for a distribution vendor or a hardware vendor, but there are a lot of them who are paid to tweak Linux and stuff for all sorts of companies, embedded systems companies, people making video recorders, anyone using Linux. So there are a lot of people who actually are paid to work on Linux, purely in the sense that they are embedding Linux in devices or tweaking Linux, optimizing Linux for their company. Yeah. But yeah, those numbers sound about right.
Okay, you're going to be around for the rest of the day?
Yes.
Wonderful. So I guess for all the other questions, we have the rest of the day. And thanks a lot, Anko.
And since it is the first time for you to be in Switzerland, we also have you a little gift, the Swiss Cyber Tool, which is branded by our association, CH Open. If you don't know CH Open, you can grab a flyer outside and become member and even company member. So,
Thank you.
Thank you.
Good job I'm going back by train, not flying.
That's good.